So, what if you could give AI superhuman vision? Today, we're diving into a system called Event Hub, and you can think of it like a factory. But instead of building cars, it manufactures perfect data to train the next generation of super sensing AI. Let's pull back the curtain and see how this whole thing works.
Okay, this right here, this is the end game. This is what we want. A perfect 3D understanding of the world, where an AI knows the precise distance to every single point it sees. You know, the kind of flawless vision a self-driving car or an advanced robot absolutely needs to have.
But here's the multi-million-dollar question, right? An AI is only ever as good as its teacher, as the data it learns from. So what happens when that perfect data, the so-called ground truth, is actually incomplete and full of holes? And that brings us right to the heart of the problem. There's a massive bottleneck that's holding this whole vision revolution back. And you guessed it, it all comes down to the data. Now, to get around the problems with normal cameras, a lot of cutting-edge systems use something called an event camera. These are wild. They don't take pictures in the way your phone does. Instead, every single pixel acts like a tiny motion detector, only firing off a signal when it sees a change in brightness. This means you get zero motion blur and amazing performance in really bright or dark scenes. They're a total game changer, but they need very special, very high-quality data to learn from. And this slide, this just says it all. On the left, that's the kind of training data we usually have to work with. It comes from LiDAR sensors, and as you can see, it's sparse. It's like a few scattered dots in the dark. And on the right, that's the goal, a complete, dense, perfect map. The huge gap between these two is the problem we need to solve. See, LiDAR has some pretty serious issues when you're using it for ground truth. For one, you only get these sparse points, not a full picture. And trying to capture something that's moving? Forget about it. By the time you scan it, it's already gone. Plus, it gets totally confused by anything reflective or transparent, like a car window or a puddle. On top of all that, these setups are incredibly expensive and complicated. It's just not an ideal solution. And that's exactly where Event Hub steps in. It takes a look at this whole mess and asks a pretty radical question. Instead of trying and failing to capture perfect data in the real world, what if we just made it ourselves? Welcome to the Data Factory. And here it is. This is the blueprint for the entire factory. The core idea is to take something we have tons of, just regular color images, and feed them into this incredible pipeline. And what comes out the other end is not just perfect 3D depth maps, but also the flawless synthetic event data that goes with them. Now, Event Hub is smart. It's got a two-pronged attack. The first path is the full-on factory mode. It takes a bunch of regular pictures and uses a mind-bending technique called novel view synthesis to build a complete 3D scene. From that perfect virtual world, it can then generate all the perfect data it needs. The second path is more of a clever labeling system. If you've already got some event data but no good 3D map for it, it uses other powerful AIs to create super accurate proxy labels for what you already have. Okay, so let's get into the nitty-gritty. How does this factory actually create motion where there isn't any? It all starts with crafting a virtual path for a camera to follow, and this is where things get really cool. Right, so here's the first major hurdle. Event cameras, by their very nature, only see change. If your 3D scene is built from static photos, well, nothing's moving. It's a frozen moment in time. So to generate any event data at all, you have to create the illusion of motion. You have to fly a virtual camera through the world you just built. And here's how they pull it off. On the left, you can see the system first looks at where the original photos were taken from and plots out a safe path between them on a flat 2D map. Then, and this is the cool part, it takes that simple path and turns it into the smooth, swooping 3D trajectory you see on the right. It uses these elegant mathematical curves to connect the dots, creating a movement that feels natural and fluid, like you're actually walking through the scene. But flying this virtual camera creates another technical headache. How many frames, or snapshots, do you need to render along that path? Render too few when the camera is turning fast and you'll get garbage data. Render too many all the time and you're just burning through computing power for no reason. Event Hub's solution is brilliant. It's called motion adaptive rendering. It constantly calculates how fast the virtual view is changing. If the camera is moving slowly, it renders fewer frames. But the second it speeds up or makes a sharp turn, it automatically starts rendering more frames, but only when and where they're needed. It's the perfect balance of quality and efficiency. So we've manufactured all this data. But how do we know it's any good?
Let's talk about the factory's quality control department, the process that ensures all this data isn't just plentiful, but that it's also incredibly precise. This whole process is called depth regularization. But honestly, the best way to think about it is just as a series of automated quality checks. The system uses these things called loss functions to basically cross-reference the 3D maps it's creating against a bunch of different rules and expert opinions to find and fix errors, constantly pushing the data to be more and more accurate. So here's what's on that quality control checklist. First, a check called ln_mean/med does an internal consistency check. It looks at the geometry of the 3D scene to make sure all the surfaces and angles make physical sense. Then, Sparse checks the new, dense map against the original sparse LiDAR points to make sure it's still grounded in reality. But the real heavy hitter is that middle one, LDAV2. This check basically brings in an outside consultant, a super powerful AI expert called Depth Anything V2, and asks it, hey, does my map look right to you? And the impact of bringing in that expert is just insane. This quote from the paper says everything you need to know. Just by adding that one check, by getting a second opinion from Depth Anything V2, they cut the amount of error in their final depth maps by 25%. That is a massive, massive improvement from one single incredibly smart step. So, the factory works, and the quality control is top-notch. But does all this lead to smarter AI? Does it actually result in better vision? Let's take a look at the results. Okay, this table tells such a powerful story. Up top, we've got a model trained the old way, using real sparse LiDAR data. Its error rate is about 4 pixels. Not bad. But now, look at the bottom line. That's a model trained entirely on EventHub's manufactured data. Its error rate is down to just 2.53 pixels. That's a nearly 40% improvement. The data from the factory isn't just as good as the real thing, it's significantly better. But believe it or not, the story doesn't even end there. In a really amazing twist, it turns out that this knowledge can flow both ways. The new, super smart event-based model can actually turn around and teach the original AI models how to see better. Take a look at this. This is a depth map from a standard AI trying to understand a really tough nighttime scene. The original model really struggled with this. But what you're seeing here is the after picture. This is the result after that AI got some extra training from its new EventHub-trained cousin. The event model literally taught the regular camera's AI how to see better in the dark. It closes the loop between them. And all of this brings us to one final huge idea. EventHub proves that we don't always need to go out and capture perfect data from the real world. We can actually manufacture it. So if collecting data is no longer the main bottleneck, what is? What's the next great challenge? The next frontier we need to cross to build AI that can truly see and understand our world?